In order for us to isolate the substitution effect in panel B, we'll now do what we always do. We'll start with the final magenta budget constraint and then shift it in parallel until it's tangent to the original indifference curve. This tells us how much compensation is required in order to keep you just as happy as before. And since an interest in the interest rate for savers is a good thing, we would have to have negative compensation to make you just as well as you were originally. Bundle B is then the tangency between the original indifference curve and the compensated budget that contains the same opportunity costs as the final budget. Moving from bundle A to bundle B requires decreasing consumption this summer and increasing consumption next summer. Put differently, moving from A to B requires us to save more now in order to be able to consume more in the future. This substitution effect tells us what it always tells us: consume less of what's become relatively more expensive and more of what's become relatively cheaper. An increase in the interest rate causes current consumption to be more expensive, because by consuming $1 now, we're giving up more in future consumption than we did before. It also makes future consumption cheaper, because for any $1 in future consumption, I now have to give up less than I did before.